Hello student, here is the question that torque required to hold a small circular coil of 10 turns, torque required. So there is a coil of turns that equal to 10, so n is equal to given to you, that's equal to 10 turns. Okay, so area is also given to you, that's equal to 2 into 10 raised to power minus 4, that's A. Okay, now current in this is equal to I is equal to 5 ampere. Okay, so in the middle of the long solenoid, this long solenoid, that's a long solenoid which you have in the middle of this one, you have this coil. Okay, so on the axis is the solenoid and here is the coil which you have, number of turns is given to you in that coil. Okay, so here is the coil which you have. About this coil, it is given to you, and the long solenoid number of turns, the n value is given to you for this solenoid, that's equal to n is equal to 10 raised to power 3 turns per meter. Okay, so that's turns per meter. Now here is the current in current carrying is so long solenoid, current in this solenoid is 3 ampere, or this current is in 5 ampere in this one. Okay, so here is the 5 ampere. Now 5 ampere current in this coil, and in solenoid that's a 3 ampere current along the axis perpendicular to the axis of the solenoid. You have to calculate the torque. So torque formula is given by torque is equal to m vector cross b vector. Okay, now you have to calculate the m vector. So for m vector, that formula for m vector is n into I into A if there is one coil. Okay, so if there are n number of coils, so you will write n into I into A. Okay, so I am writing that's a A vector. Okay, so I can convert this is equal to n into I into A vector. Okay, so if I am writing this formula again, so you will write it like that. So n into I into A vector cross B vector. Okay, so torque required to hold, and it's given to you axis perpendicular to the axis of the solenoid. Okay, so this axis is perpendicular to the solenoid axis, so the A vector cross B vector is equal to n into I into A into B into sine the value of theta will be equal to so it is perpendicular to the axis of the solenoid, so you can write from that that's equal to that's coming out to be 0. Okay, so sine theta that's coming out to be 90. Okay, so perpendicular, so sine 90 will be equal to, because axis is perpendicular to the axis of the solenoid, so angle will be equal to angle between magnetic field and area vector will be equal to 90. So you will write from here that's n into A into B. Okay, so here number of turns in the coil, and B can be written as on the axis of solenoid. You can write B that's equal to mu naught into n, number of turns per unit length, that is the n, mu naught into n into I. Okay, so I can just put the value over there. So that's equal to n into I into A into value of B, that's equal to mu naught into n into I. Okay, so just put the values. So you will get from there that's mu naught into capital N number of turns, small n number of turns per unit length, and that's the I square, and that's equal to A. Okay, so here put the values. Mu naught is 4 pi into 10 raised to power minus 7. Number of turns in this coil, that's equal to 10. Number of turns 10, and number of turns per unit length is given to you, that's equal to 10 raised to power 3, and I square current that's equal to, that's the I1, that's the I1 current, and that's the current in I2. Okay, so in solenoid that's the current I2, so you just multiply the current I1 and I2. So here is the I1 and here is the current I2, both the currents are not same. Okay, so you have to just multiply it. So both the current, that's equal to I1 and that's I2. Okay, so multiplication of both the currents, one current is 5 ampere and current in this one is 3 ampere, so multiply it. So 15 multiplied by 3. Now I1 I2, and that's the cross section area, that's equal to 2 into 10 raised to power minus 4. Okay, so just multiply it, you will get the answer, that's equal to 10 raised to power 4. It will cancel out by that one. Okay, so now multiply it, you will get the answer 13 into 4, that's equal to 6, and 6 will multiply by 15, you will get the 6 will multiply by 15 and you will get the 90. Okay, so from there you will get the value mu naught into 4 pi into 10 raised to power minus 7, okay, multiply by 90. Okay, so from here you will again multiply it, you will get the value that's equal to 4 pi 36 pi into 10 raised to power minus 6. Okay, now your answer here is the torque which you have, that's a Newton into meter. So 10 raised to power minus 7, it's just check it out, current is coming out to be 0. It's not 5 ampere, it's 0.5 ampere. Okay, so just 0.5, so here 0.5, just 0.5. now so here it will multiply, is some calculation you do 0.5 will multiply by that one, 0.5 will multiply by 2 and it will become 1. Okay, so it will become 1. Now you have to multiply that 3 with 4 pi, you will get 12 pi into 10 raised to power minus 7. Okay, so 12 pi into 10 raised to power minus 7. So according to that, your option number first is the correct answer. Okay, so option number first is the correct answer of this question. Okay, thank you.